incredible researcher, professor at University of Toronto. He discovered the idea of backpropagation, which allows the neural network to learn. And as you know, for the audience, software historically was humans applying first principles in our thinking to describe an algorithm that is then codified, just like a recipe that's codified in software. It looks just like a recipe. How to cook something looks exactly the same, just in a slightly different language. We call it Python or C or C++ or whatever it is. In the case of deep learning, this invention of artificial intelligence, we put a structure of a whole bunch of neural networks and a whole bunch of math units. And we make this large structure, it's like a switchboard of little mathematical units. And we connect it all together. And we give it the input that the software would eventually receive. And we just let it randomly guess what the output is. And so we say, for example, the input could be a picture of a cat. And one of the outputs of the switchboard is where the cat signal is supposed to show up. And all of the other signals, the other one's a dog, the other one's an elephant, the other one's a tiger, and all of the other signals are supposed to be 0 when I show it a cat, and the one that is a cat should be 1. And I show it a cat through this big, huge network of switchboards and math units, and they're just doing multiplies and adds, okay? And this switchboard is gigantic. The more information you're going to give it, the bigger this switchboard has to be. And what Geoff Hinton discovered was a way for you to guess that, put the cat signal in, put the cat image in, and that cat image, could be 1 million numbers, because it's, a megapixel image, for example. And it's just a whole bunch of numbers, and somehow from those numbers, it has to light up the cat signal. Okay, that's the bottom line. And the first time you do it, it just comes up with garbage. And so it says the right answer is cat. And so you need to increase this signal and decrease all of the other, and backpropagates the outcome through the entire network. And then you show it another, now it's an image of a dog, and it guesses it, takes a swing at it, and it comes up with a bunch of garbage. And you say, no. The answer is, this is a dog. I want you to produce dog. And all of the other other outputs have to be 0. And I want to backpropagate that and just do it over and over and over again. It's just like showing a kid, this is an apple, this is a dog, this is a cat. And you just keep showing it to them until they eventually get it. Okay, well, anyways, that big invention is deep learning. That's the foundation of artificial intelligence. A piece of software that learns from examples. That's basically machine learning, a machine that learns. And so one of the big first applications was image recognition. And one of the most important image recognition applications is radiology. Mm. And so he predicted about 5 years ago that in 5 years' time, the world won't need any radiologists because AI would have swept the whole field. Well, it turns out AI has swept the whole field. That is completely true. Today, just about every radiologist is using AI in some way. And what's ironic, though, what's interesting is that the number of radiologists has actually grown. And so the question is why? That's kind of interesting, right?
It is.
And so the prediction was, in fact, that 30 million radiologists will be wiped out. But as it turns out, we needed more. And the reason for that is because the purpose of a radiologist is to diagnose disease, not to study the image. The image studying is simply a task in service of diagnosing the disease. And so now, the fact that you could study the images more quickly and more precisely without ever making a mistake and never gets tired. You could study more images. You could study it in 3D form instead of 2D because, the AI doesn't care whether it studies images in 3D or 2D. You could study it in 4D. And so now you could study images in a way that radiologists can't easily do, and you could study a lot more of it. And so the number of tests that people are able to do increases. And because they're able to serve more patients, the hospital does better. They have more clients, more patients. As a result, they have better economics. When they have better economics, they hire more radiologists because their purpose is not to study the images. Their purpose is to diagnose disease. And so the question is, what I'm leading up to is ultimately,